Understanding antibiotic resistance. In the world of modern medicine, antibiotics have long been heralded as miracle drugs, capable of combating bacterial infections and saving countless lives. However, as their use has become widespread, a new and ominous threat has emerged: antibiotic resistance. This phenomenon occurs when bacteria develop the ability to withstand the effects of antibiotics, rendering these life-saving medications ineffective. Understanding the intricacies of antibiotic resistance is crucial for tackling this growing global health concern. What are antibiotics and how do they work? Antibiotics are medications designed to treat bacterial infections by targeting specific components or processes within bacterial cells. They work by either killing bacteria outright, bactericidal, or inhibiting their growth, bacteriostatic. Common targets include bacterial cell walls, protein synthesis machinery, or metabolic pathways. By disrupting these essential bacterial functions, antibiotics weaken or eliminate the bacteria, allowing the body's immune system to effectively clear the infection. The mechanisms of antibiotic resistance. Antibiotic resistance is a natural evolutionary process that occurs when bacteria develop mechanisms to resist the effects of antibiotics. These mechanisms can vary widely depending on the type of antibiotic and the specific bacteria involved. One common mechanism involves the modification of antibiotic targets, rendering them ineffective. For example, bacteria may alter the structure of the protein targeted by the antibiotic, preventing the drug from binding and exerting its effects. Another mechanism involves the production of enzymes that degrade or modify the antibiotic, rendering it harmless to the bacteria. Additionally, bacteria can develop efflux pumps that actively remove antibiotics from the cell, reducing their concentration to subtherapeutic levels. Causes of antibiotic resistance. The rise of antibiotic resistance can be attributed to a multitude of factors, but one of the primary drivers is the overuse and misuse of antibiotics. In human medicine, antibiotics are often prescribed unnecessarily for viral infections, against which they are ineffective. Patients may also fail to complete their prescribed antibiotic courses, leading to incomplete eradication of the infection and potential development of resistance. Furthermore, antibiotics are extensively used in agriculture to promote growth and prevent disease in livestock. This agricultural use of antibiotics creates selective pressure, favoring the emergence of resistant bacteria that can spread to humans through food, water, or direct contact. Consequences of antibiotic resistance. The consequences of antibiotic resistance are far-reaching and profound. Infections caused by resistant bacteria are associated with increased morbidity, mortality, and healthcare costs. Common infections, such as urinary tract infections, pneumonia, and skin infections, are becoming increasingly difficult to treat due to antibiotic resistance. In severe cases, infections may become untreatable, leading to prolonged illness, disability, and death. Moreover, the emergence of multi-drug-resistant bacteria complicates treatment options, leaving healthcare providers with limited or no effective antibiotics to combat infections. Global impact of antibiotic resistance. Antibiotic resistance is a global health crisis that transcends geographical boundaries. It affects people of all ages, genders, and socio-economic backgrounds. Low- and middle-income countries are particularly vulnerable due to limited access to healthcare, inadequate sanitation, and over-the-counter availability of antibiotics. However, antibiotic resistance knows no borders, with resistant bacteria capable of spreading rapidly through international travel and trade. The interconnected nature of our world necessitates coordinated efforts at the global level to address this urgent threat. Addressing antibiotic resistance. Combating antibiotic resistance requires a multifaceted and coordinated approach involving various stakeholders, including healthcare professionals, policymakers, researchers, and the public. Key strategies include promoting responsible antibiotic use through education and stewardship programs, implementing infection prevention and control measures in healthcare settings, investing in research and development of new antibiotics and alternative therapies, and fostering global collaboration to share data, resources, and best practices. Additionally, raising public awareness about the importance of prudent antibiotic use and the consequences of resistance can empower individuals to take action in their communities. Conclusion. Antibiotic resistance poses a significant threat to public health, requiring urgent and concerted action from all sectors of society. By understanding the mechanisms, causes, and consequences of antibiotic resistance, we can work together to preserve the effectiveness of antibiotics for future generations. Through responsible antibiotic use, infection prevention, research, and global collaboration, we can mitigate the impact of antibiotic resistance and safeguard the effectiveness of these life-saving medications. The time to act is now, for the sake of our health and the health of generations to come. Let us join forces to combat antibiotic resistance and ensure a healthier, safer future for all. If you liked the video, give it a thumbs up and subscribe to the channel.